Okay, we're continuing now with the notes for section 7.2 in Algebra 2. And we learned in the previous video that you can multiply square roots. If they're both square roots, you can multiply and consolidate. So we're going to make one square root out of this, 2 times 14 to start with. And when you take x to the second times x to the third, you add your exponents. Then you split it apart, and the goal here is to get a perfect square in the front. Well, if you take 28 divided by x on your y equals line and go to your table of values, you'll see that 4 times 7 is the only way to break apart 28 and get a perfect square in the front. All right, our index here is invisible. It's a 2. And with that index of 2, we got trouble here because 5 doesn't divide by 2. So like we did last time, you're going to lower that 5 to 4 and put the extra x in the back. And then you're going to take the square root of this perfect square part up here. The square root of 4 is 2. And then if you take this exponent and divide it by the invisible 2 that's out there, you get your new exponent of 2 here. And your 7x is the part you can't do anything about. Okay, on this one, if you were checking it, you would probably want to store a number for x. I typically store 1.23, and you would then type the original problem and type the result down here, and you should get the same numerical value for both. Okay, we got another one, number 10 here, and this one involves cube roots. The cube root of 4x to the 5th times the cube root of 6x to the 8th. If you put these together here, you get the cube root of 24x to the 13th power. And then we're going to break this back up again. This time we're trying to get a perfect cube in the front, and the only perfect cube that's less than 24, well, there's one, but we usually don't consider that one, is the number 8, and 8 times 3 works just fine. Now the 13th power, we're trying to get something that divides by 3, so you're going to have to lower that 1 to get 12th power. That divides by 3, and you put the extra x that you took away in the back. Now we have the cube root of 8, which is just 2. And when you take the 12 divided by the index of 3, you get your new exponent of 4. And then you have the junk pile back there. It's not really a junk pile. It's part of your answer, so don't throw it away. Okay, on the next one here, we have on the outside 6 times 4. But we're going to combine the cube roots in the back. And 2 times 24 is 48. And the x times the x to the third is x to the fourth. Okay, so far so good. Let's keep this 24 out here, and we're going to try and break apart this radical. The perfect square that goes into 48 is 8. There's not a whole lot of perfect squares less than 48, namely 8 and 27. That's the only choices. So it's 8 times 6 is what we're going to do. And then we need a power that divides by 3. So we have to decrease this to x to the third and put that fourth x in the back. And now we have 24 times 2x cube root of 6x. And we make that 48x cube root of 6x. And the 2x here is what you get when you simplify the 8x cubed with a cube root on it. Okay. The next section introduces us to a similar rule. It's not the product rule, but the quotient rule. And this one says if you start out with a division and you've got matching radicals, so for instance, this could be a cube root and another cube root, that you can put it together underneath one tall, all-encompassing cube root, or whatever root it is. You do have to have matching indices. So you wouldn't, for instance, use this rule if you had a square root and a cube root in the same problem. Most of the time, you're not going to be given that anyways. Okay, so let me give you an example here. You're going to take this square root of 125 divided by square root of 5, and you're going to make it square root of 125 over 5. Now, if you're lucky, this is going to simplify inside, and sure enough, 125 divided by 5 is 125 divided by 5 is 25, and that square root just turns out to be 5. All right, this next one here, we have matching square roots. They're same indices, so we're going to make one tall hat out of it. And you're going to go 24x to the 5th, y to the 9th, over 3xy squared. Okay, so now, and you're lucky if this happens, you're going to get a simplified version here. 24 divided by 3 is 8. And then this part here, we're going to be subtracting exponents. There's a 1 implied there. So that'll become x to the 4th. And then we subtract exponents on this one too. And that 9th power up there, take away the 2nd power, gives y to the 7th. Okay, now all of these simplify. Well, actually 8 is not a perfect square. So we're going to have to split this up and put perfect squares only in that front part. 8 breaks up as 4 and 2. The x to the 4th is good to go since 4 divides by the 2 that's implied out there, so we'll put it all up front. But this 7th power doesn't divide by 2, so you'll have to decrease it to 6th power and put the extra y in the back. And now everything's ready to simplify. Square root of 4, square root of x to the 4th, square root of y to the 6th, and I made a mistake there. Let me back up here. Square root of x to the 4th, square root of y to the 6th, and then our extra square root of 2y there, which we can't do anything about. So there's our final answer. Okay, I'll do one more like that. And what we have here is cube root of 192x to the 10th over y to the over 3x. Now, when you simplify underneath there, 192 divided by 3 is 64. And if you take the powers and subtract them, 10 minus 1 gives you the new power of 9. And this one, there's no fancy stuff needed. They're both perfect cubes. The cube root of 64 is just 4. And if you take x to the 9th, that 9th power divided by that 3rd power, you get your 3rd power for your answer there. Okay, and we'll pick up on the next section, starting with problem 15 in the next video.